Mathematics Level 4, Topic 3, Space, Shape and Measurement. Welcome to Topic 3 of the Mathematics Level 4 Support Package. Topic 3, Space, Shape and Measurement, Module 2, Geometry Part 1. Module 2, Session 1. Session 1 will cover Subject Outcome 3.2, Geometry Introduction. Learning Outcome 3.2.1, Geometry of Straight Lines and Triangles. Now we'll watch a video of the Introduction to Geometry by a lecturer.
Hi, I'm Ivan Mapaling. Let me introduce geometry.
Subject Outcome 3.2, Geometry Introduction. Welcome back. We'll now look at Subject Outcome 3.2, the Geometry section. This is a big section of work, and almost all of it is new, as students have only studied the theorem of Pythagoras at Level 2. The best way to handle geometry in Level 4 is to build a really good toolbox for students. Geometry makes up 25% of Paper 2. This is broken down as roughly 5 to 8% analytical geometry, 17 to 25% ordinary geometry. This is quite a large portion of Paper 2. Let's take a look at Subject Outcome 3.2 and its learning outcomes in more detail. You will find them on page 10 of your subject guidelines. Subject Outcome 3.2, Explore, Interpret, and Justify Geometric Relationships. By the end of the subject outcome, students should be able to use geometry of straight lines and triangles to solve problems and to justify relationships in geometric figures. State and apply theorems of circles. Both of these learning outcomes are new in Level 4. Learning Outcome 3.2.1, Geometry of Straight Lines and Triangles. We are going to start the session off with an activity. Please work in groups. Let's now begin to build our basic geometry toolbox for students. Remember, we want our geometry to unfold piece by piece for students. A good place to start our toolbox is with information about lines and angles from previous grades. Students need to know the definitions of the acute angle, which is an angle smaller than 90 degrees, the right angle, which is a 90-degree angle, the obtuse angle, which is between 90 degrees and 180 degrees, the straight angle, which is an angle of 180 degrees and forms a straight line, the reflex angle, which is between 180 and 360 degrees, and the revolution, which is 360 degrees. Students need to understand and be able to apply relationships between angles, such as adjacent angles, supplementary adjacent angles, which add up to 180 degrees, vertically opposite angles, which are always equal, and complementary angles, which add up to 90 degrees. The last set of line-angle relationships are those concerned with the angles formed when a transversal intersects two parallel lines. Co-interior angles are supplementary, so B plus E equals 180 degrees, and C plus H equals 180 degrees. Alternate exterior angles are equal, so A is equal to G. Notice that the angles are always the internal corners of a Z shape, and D is equal to F. Alternate interior angles are also equal, so B is equal to H and C is equal to E. Corresponding angles are equal, so A is equal to E, B is equal to F, C is equal to G, and D is equal to H. Looking at this diagram, we should also note the pairs of vertically opposite angles that are equal. So A is equal to C, B is equal to D, E is equal to G, and F is equal to H, and that the angles around a point add up to 360 degrees. So, A plus B plus C plus D equals 360 degrees, and E plus G plus F plus H equals 360 degrees. We will now watch a video with some line geometry tips.
Geometry, you first need to have a knowledge base of certain things. But geometry is about lines, figures, circles, etc., etc. In other words, when we're considering lines, you have parallel lines and you have lines that crosses one another. And when you're looking at about parallel lines, that's why I'm saying maths is fun, because that's exactly what parallel lines is all about. Parallel lines is fun. Now people might wonder why it's fun. If you look at the F means you have corresponding angles. If you look at the U means you have co-interior angles, but you also need to take note that adds up to 180. And if you look at the N means you have alternate angles. And that's a nice way of remembering parallel lines. And when you look at lines in general, angles on a line, obviously that adds up to 180. But there's a nice word for adds up to 180. By using the word supplementary, it means exactly the same as adds up to 180. Then you have another word, complementary. It means it adds up to 90. And that is the information that you need about lines.
It's also important to revise the geometry of triangles with students, as triangles will come up often in Level 4 geometry. We can classify triangles according to how many equal sides and equal angles they have. Equilateral triangles have all three sides equal, and each angle is equal to 60 degrees. Isosceles triangles have two equal sides, and the angles opposite the equal sides are equal. Scalene triangles have all three sides of different lengths, and all three angles will be different too. We can also classify triangles as follows. A right-angled triangle has one angle equal to 90 degrees. An obtuse-angled triangle has one obtuse angle. An acute-angled triangle is a triangle with all three angles acute. Students also need to know these facts about triangles. The sum of the angles of a triangle is always 180 degrees, and the exterior angle of a triangle is equal to the sum of the opposite two interior angles. We will now watch a video with some triangle tips.
When you put three lines together, you end up getting a triangle. And there again, you got right angle triangles where one of the angles are 90 degrees. Then you have different type of triangles. But what is important, there's only two things that you need to know about the triangle. I'm just analyzing and highlighting the different information that you first need to know before you can apply it. Triangles, interior angles adds up to 180 degrees. The exterior angle is equal to the sum, very important, of the opposite interior angles. And this information, you need to know it first.
With geometry, students need to know this toolbox backwards. Let's quickly test our knowledge on straight line and triangle geometry. We're going to do an activity that you could try in your classes. In each case, call out what kind of angle or triangle fact you see. What kind of angle is this? It's an acute angle. What kind of triangle is this? An isosceles triangle. What kind of triangle is this? An obtuse angled triangle. What kind of triangle is this? It's a scalene triangle. What is the relationship between these angles? Co-interior angles are supplementary, meaning they add up to 180 degrees. What is the relationship between these three angles? The sum of the interior angles of a triangle is 180 degrees. What is the relationship between these angles? Vertically opposite angles are equal. What is the relationship between these angles? Corresponding angles are equal. What is the relationship between these three angles? The exterior angle of the triangle is equal to the sum of the opposite two interior angles. What is the relationship between these angles? Alternate exterior angles are equal. What is the relationship between these angles? Angles A and B lie on a straight line and they are supplementary. Thus, they add up to 180 degrees. What is the relationship between these angles? Alternate interior angles are equal. What kind of triangle is this? It's an equilateral triangle. We will now watch a video with some tips on geometry reasons.
I always say geometry is like you're a lawyer, you're a mathematical lawyer. And now you need to prove with the aid of evidence, but you need to know the laws first so that you can prove with evidence that whatever is required, you will be able to answer it. For example, a simple example, if you have a straight line with a line going past it and then they give you a value of 50, then obviously you need to, you know, that's adjacent supplementary angles. Obviously you need to know the other angle should give you 180 minus that 50, that should give you 130. But now the learners know it's 130. They know. Yeah, they write 130. But why? I mean, if you're in court, you lose the case. Because it's about why. And that's the problem that our lecturers, in a sense, and even our learners suffer with. Because they don't know the whys. And geometry goes about the whys. And in order to know the whys, you need to become familiar with all the theorems, which in my terms I call, as a mathematical lawyer, your mathematical laws and your mathematical theorems.
Teaching tip. As you've just heard, in geometry, the way that students write out the answers to problems is very important. Make sure that you guide the students to use the correct notation. They should always show all the steps in solving a problem. They must give the reason for each step, otherwise it looks like guesswork. Let's watch a lecturer teach an example on straight line geometry.
Let's look at this geometry problem that you all see here. The question is, calculate the numerical values of x and y, giving reasons for your answer. A nice approach to do any geometry problem is you divide it into two columns, where your first column will be your statement. and your second column will be your reason. And that is how we will approach these problems. In other words, for any statement that you make, there must be a reason to justify that statement. Now let's look at what do we have here. We only have lines here. We have line AB, we have line CD, and we have line EF. And let's look at the theorems about these lines. You all can see there that we have 1, 2, 3, 4, 5, 6 angles around point A. And the theorem states that angles around a point adds up to 360 degrees, which means that after we've solved x and y, we will obviously, once we tested it, x plus 2y plus 3y plus y plus 2x plus 90 should all add up to 360 degrees. That's the first theorem. The second theorem is, if we consider line EF, and you look on that side, 2y plus x plus 90 are all adjacent angles. And they are adjacent supplementary because those three angles will add up to 180 degrees. You can also consider CD exactly the same as well as AB. And then the third theorem that comes out of here is, if you look at angle X is vertically opposite to angle Y, meaning that X is equal to Y. Also, 2y is equal to 2x, but also 3y is equal to 90 degrees. And it's advisable to always, when you need to calculate angles, start with your given information. In other words, in order to solve this, we will be able to solve y first. 3y is equal to 90 degrees. And we can start with it. 3y is equal to 90 degrees. What is the reason there? It is vertically opposite angles, which means y will be equal to 90 divide by 3, and that is equal to 30 degrees. Obviously, once we got y, then x is equal to y. Angle x is equal, and that is also equal to 30 degrees. Why? Because that is vertically opposite angles. Now we have solved angle x as well as angle y. Now let's do a test based on the other theorems that I've explained earlier on. Let's look at line EF. We look at line EF, and we're going to consider now adjacent supplementary angles. From line EF, angle x plus 2y plus 90, that should give us 180 degrees. Now let's see if it's the case. What is angle x? Angle x is 30 plus what is y? It's also 30 plus 90, and if we add this up, it adds up to 180 degrees. Why should it be like that? Because this is the other reason, adjacent. And it's very important when we write down our reasons that we write it as clearly as possible. Adjacent supplementary angles.
Now try this example on your own or with the person next to you. Calculate the numerical values of x and y, giving reasons for your answer. We will now watch a lecturer going through the solution.
Let's consider the following example. The question is, calculate the numerical values of x and y, giving reasons for your answer. What do we have here? We have two parallel lines in green, AB in parallel with CD, and then we have the line EF. And when we think about parallel lines, it means we're going to have some fun. The F is for corresponding angles. The U is for co-interior angles. And the N is for alternate angles. So in other words, by looking at that parallel lines, we're going to look at either corresponding or co-interior or alternate angles. And when we consider this diagram here, if we look at the corresponding angles and we consider 5x, then 5x, if you look at the F, is corresponding to GHD, and that will be our starting point because we start with the angle furthest from the other combination, which means we can then make our first statement by saying that GHD is equal to 5x. What is our reason? Very important. AB is in parallel with CD. And because of that, that's when you will have corresponding angles. That means we can then put 5x there. Now, if you look at the 5x and the x, obviously, and we look at line EF, then you will agree that 5x plus x is equal to 180 degrees. The x and the 5x are adjacent angles. But they are supplementary. Supplementary because they add up to 180. As a result, now we can find x. 6x is equal to 180. Therefore, x is equal to 180 divided by 6, which gives you 30 degrees. Once we got x, obviously now there's two ways, but let's take the easiest way. We can now look at line CD and we can say that x plus y is equal to 180 degrees, which is also adjacent supplementary, and by means of that we can find y, or we can say that 5x is equal to y, and then we can directly substitute the calculated x value. So let's take the easiest route by saying y is equal to 5x. Y, that is vertically opposite angles. And now we can just direct substitute. 5 times 30 and y is equal to 150 degrees.
Now try this triangle example on your own. Your facilitator will give you a solution on a handout. And now try another mixed example on your own or in pairs. Now we will watch a lecturer working through the solution.
Let's consider the following example. Calculate the numerical values of A, B, C, and D, giving reasons for your answers. What do we have here in front of us? We have parallel lines, AB in parallel with CE, in parallel with GH. We also have AF in parallel with BG. And by just considering the concept of parallel lines, immediately we think about fun. If you look there, can you people see there? That is co-interior angles, meaning that if that is 100, then that one should be A plus 100 should give me 180 degrees. So immediately A there should be equal to 80 degrees. And if I add those two, I will get 180 degrees. Then I look further there. Can you people see here? AB is in parallel with GF, meaning I'm looking now at N. Can you people see the N concept there? It means that B will be equal also to 80 degrees, because those are alternate angles. By looking here, D, can you people see this triangle here? And D is your exterior angle of that triangle. And what's the rule? Your exterior angle is equal to the sum of the opposite interior angles. So D should then be equal to 80 plus 35, which gives you 115 degrees. And then we can calculate C from two sides. C and D are adjacent supplementary angles, which means C will be 180 minus 150 degrees, or I can use the sum of the interior angles of the triangle, where 35 plus 80 plus C must give me also 180 degrees. So C therefore will then be equal to, it's 120, which is 5, and then obviously it's going to be 65. So now on our diagram, you can even test it from the other way, 65, 70, 100, 180 degrees. On the diagram, we have solved now all the values of A, B, C, and D. But that means nothing. We need to now write it down why we have done that. So let's start first with A. A is equal to 180 degrees minus 100, and that is equal to 80 degrees. Why is it like that? AB, AF, we need to state clearly which lines are in parallel. AF is in parallel with BG, and because of that we have co-interior angles. Right, we have solved A. B is equal to A, and that is equal to 80 degrees. Why? Because AB is in parallel with GH or GI. That is alternate angles. Now we have B. We can immediately move to D is equal to B plus 35. Why is that? Exterior angle equals sum of opposite interior angles. Therefore, we substitute the value of B, 80 plus 35, and that is equal to 115 degrees. And then, obviously, now we can calculate C. C plus D is equal to 180 degrees. What is the reason? That is adjacent. Why? Because they're next to one another. Adjacent. Supplementary, because they add up to 180. Therefore, C is equal to 180 degrees minus what is D? 115 degrees equals 65 degrees.